Okay, so I mean, we're done the core content. If you have places to be, you should head off now, because we got 10 minutes left. We've got this topic called Teamwork Thursday, where essentially we just try and spend 10 minutes at the end of every week, just talking about something to do with teamwork. Largely, the point of this was that I sat down last term and figured out that there's a handful of a small set of stories that, um, you know, I've been lucky enough to have experience with, uh, interacting with, and um, wanted to try and chat through a few of these. I've actually got this list. Most of it kind of comes from my time in, a mix of, some student groups and some startup stuff as well. But these are kind of just some general-ish topics that I've written down before, where we have some fun little stories attached to them. Stories about some stuff that's happened and some lessons that have been made. Um, so there's a bunch of stuff around, working as a team, functioning well, leadership, all of that in the context of SunSwift, which is solar racing stuff, and then there's one on RoboCup. It's already, yeah, this is being recorded. Um, and then there's some broad concepts you can take away regarding, helping get people working together, resolving disagreements, managing relationships, etc. So typically what we're going to do is, I mean, we only have 3, 4, 5, 7, 8, 9, 10. We only have like 7 of these lectures or something, if that, because we might run out of time in other weeks. But just looking at this, is there anything in particular that people are interested in? I usually would just start with the RoboCup story because, uh, it's topical because you've just learned Git and people are kind of interested in teamwork software. So please express your opinions now because we've got just under 10 minutes left. Um, and if there's no clear opinion, I'll just go with the RoboCup one. I'll give you like 5 or 10 seconds to. RoboCup sounds interesting. RoboCop sounds interesting, Hussein says. Okay, 2. Yep, okay, great. So, um, for a couple of years, I spent time being part of a group called RoboCup. RoboCup is a giant organization of, many different robots that try and play forms of soccer. Essentially, you have a whole bunch of them. You have little robots. You got like the small league, which literally look like Roombas playing soccer. I'm not kidding. They all run around and it's like Roombas trying to kick balls together. You have bigger ones where you have like the big league where there's like actual big scary human robots, like these ones that people build sometimes, and these ones are really scary. These are basically like big queen Roombas that run around kicking balls into goals and stuff. You have a simulation league where you actually play an entire soccer game that's like running, like on a server, like a simulated soccer game, and then you have SPL, which is kind of the most popular one because of how it looks, and this is one UNSW is involved in, and it continues to be involved in, which is where every team gets the same robot and they play soccer, and you don't get to touch the robot. They're totally standard. Teams could trade robots. You just write the software on them. These robots are super interesting. We could do like an hour and a half talk about their architecture and structure and how the code runs. But largely the short summary of how these work is that they have a number of key systems, which is they have a lot of code written to interpret what they see with their cameras, because they have 2 cameras on their face. So they need to interpret what they see as objects. They need to figure out where they exist in the world. So we call this localization, where you can see. Okay, so say you see a ball or you see a goalpost. It's like, where are you, right? Because you take for granted the fact that you as a person know where you are at all times, right? Like you're like, I'm in the kitchen. You know that because of what you can see. So there's that second step. There's a third step of actually making them know how to walk and run and kick, actually working with the joints. And then there's a fourth step of like thinking, like, what do you do? Do you go to the ball? Do you kick the ball? Do you pass the ball? Where is the ball? Where are you going to walk? Where are you going to stand? That's just like our higher order thinking. So UNSW has a team for this, where they go and write a whole bunch of code. It's super interesting, super fun kind of stuff. It's far less climatic than you would expect. It's a very slow-paced kind of thing. And the software is quite, they're not super powerful robots, right? They're not like massive supercomputers. So you have to be relatively efficient with how you write software. Anyway, the reason this group's interesting is because typically you might have about 10 people contributing to it, and it's a Git repo. And in fact, like you can actually find the Git repo online if you Google Run Swift GitHub. So what they do is they actually package up all the code and they release it as a single commit every year a lot of the time, where you can actually go and see all the code that runs on the robot bar. Typically they remove a couple of things, but it's all kind of there. And just to give some more concrete examples, if you look up some, say, I'm guessing we'll probably run till like 1102 or 1103 or something, but this isn't a RoboCup SPL UNSW, so you can actually go and like see some of these things online. And 2017, yeah, so like this is, for instance, a soccer game between us, UNSW Sydney, and a group from Dortmund, which is a city in North Rhine-Westphalia in Germany. It's like the northwest of Germany, and it's literally just robots running around playing soccer. Anyway, this is all pretext just to try and paint the picture of what it is. So it's quite honestly just soccer and then running around playing soccer. Now, the reason I mention this is because what is cool about some of this stuff is the kind of learning experiences that get to be had around teamwork and actually working together on a software project. So because you're literally just working on a code base, right? But some interesting things that kind of come out of this in terms of interacting with teams. I'm sure some of you at one point have tried to use the git commit -am command, and that's where you commit everything that is unstaged and tracked. I'm sure some of you have found that and been like, oh, that's really convenient. Or you just git added everything without looking at stuff. And you might look at me when I do git status and I manually git add things and think, oh, that seems really slow. I'm just going to git add everything. The problem with git adding everything is that you're eventually going to miss something. And there was a particular instance with RoboCup in 2016 where we were with a team member who was rushing to get code in, and was rushing so fast, and he wrote git commit am, and then he pushed some code, and then we went and put that code on the robots, and we went to play a soccer game, and as soon as the robots started playing soccer, they all literally just seg-faulted and stopped working. And that sucked. And the reason was because he pushed code to master that he didn't mean to, because he was working on some other files as part of another thing that he didn't put on the right branch. And we literally lost that game in large part due to the fact that we had this error at the start. So like it all seems really easy when you're like, oh, well, we'll just do this because I want to commit all the files. But if you don't build good habits now, you're going to do something stupid later. And I continue to see this even now in production environments and everything else. So again, remember that most habits we teach, these include things like, washing your hands, or, not putting candles near flammable things. Most of the time, it's going to be completely fine, right? You don't, like, every time you don't wash your hands, it's not like you end up in the hospital. It's just that when it actually does matter, you need to already be on cruise control, actually thinking about these things. And the same is totally true for Git and stuff. It's the fact that you need to make sure that you are building good habits now. Some other things, that kind of are interesting takeaways from group situations like this are that with a lot of code and stuff, particularly for kind of production systems, one thing that comes up a lot is actually this idea of code freezing. And it's something that you can actually even think about in terms of the leaderboard that you're running with the project, because in reality, most of the time you're writing code, you're often working to some kind of deadline. Sometimes that deadline might be a daily deployment. Sometimes it might be like a soccer game. It could be kind of anything. So one principle we really tried to stick to in RoboCup was we used to have a code freeze. And code freeze is essentially an idea where if you take master as it is at a certain time, and it doesn't matter what you haven't merged in yet. It just doesn't matter, because there is this kind of endless slippery slope right? This endless slippery slope of, oh, we just need one more thing, or if we just get this in, we'll have this little bit of an improvement. And when it came to this like soccer game in particular, which I understand is a little bit more physical and tactile than another software system, it was like, I think it was an hour and a half before the game. So an hour and a half before the game, it was like no one is touching master anymore. Like, if you want to keep working, you can keep working, but your code's not going in for this particular game. And naturally this causes a lot of tension within a team, right? Because you've been working on something that's not done, or maybe the robot is not behaving correctly. Maybe it's actually not seeing the ball on the line, which was like a kind of common problem we had, right? Because the ball's white, the line's white. And if you couldn't see it on the line, then like you'd have some bad situations. But if the code's not ready at an hour and a half, you don't merge it in. Because you see this happens all the time, right? And we did this, we'd have some code and we're like, oh, we really want this code, and we'd merge it in like 30 minutes before the game, and then we'd be rushing around trying to get the robots ready. But because we didn't have time to think about it, because we were rushing, we actually ended up breaking more things than we fixed. So like a thing I would probably encourage a lot of you to do with your projects as well is treat the leaderboard runtime like some kind of code freeze event, where at 10 a.m. on any given days in the lead up to an iteration being due, just stop working. Like, it doesn't matter what you haven't got in there. Just say, this is stable. We're not going to rush anymore. We know this isn't perfect. We know we're not going to get all the marks for it because maybe we're, trying to rush to get a few things in. But it's like, just leave it alone. You always have tomorrow, right? It's not like you die if you don't get a particular merge request in at a particular time. And this is the other reason as well why we have these continuous integration systems. It's so that all the code in master is always stable. So every time you merge to master, you should be finitely improving your code and keeping it stable, which takes the pressure off, because if you don't merge something into master, master should already still be working. And again, same kind of principles with RoboCup too. It's like you're working in a big team with many people, everyone's pushing code, and you need to make sure that you kind of have rules and systems that, are kind of like governance rules around like good software development. Yellow is actually not UNSW in this particular instance. But yeah, so this was a very kind of fun and complicated experience. The other kind of thing that actually is, that you can take away from an experience like this, and many other people in the team did, was like just code reviews again. Because, you write code, it doesn't work, you push it to robots, you lose games. So you actually want people to review your code, because I know many of you will sit around at this point and think, oh, reviewing my code, it's so annoying, I just want to merge it in, I'm done, like, let's just get it in. But that's all well and good, because what goes wrong with your code now? Well, okay, it fails a pipeline. Great, that's not that scary. But if you write code that actually breaks a system for someone, maybe it costs a company some business, maybe it stresses some students out, maybe it breaks a robot and you lose a game. Like, the reality is that if you're actually if you're actually trying really hard to work in a team, you want people to review your code because you want your code to work. Like, right, the correct code is going to be more important than code merged in quickly 99% of the time. So we're starting to bleed people now because it's past 11. I mean, this isn't really part of the core lecture anyway, so it doesn't really matter, though. I just wanted to check if people had any last questions before we wrap up, because I understand some people are curious about this who don't have class at strictly 11, and I'll chat about that for a few minutes. Are the actual robots provided? Yeah, so that you buy them from a company in Japan. They cost about $10,000 each. They're expensive little things, and they're extremely fragile. Speaking of that, I do actually have one last story. I'll tell you a funny story about software verification, because that's what we've been talking about today. I think RoboCup's still going on, yes. So we talk about software verification, right? And remember how we said that tests check the absence of bugs. They don't actually... Sorry. Tests check for the presence of bugs, not the absence of bugs. So we had a robot, one of these robots here. And what happened was that, we had our vision systems and it was working, and it was literally working for years. Like, quite literally years. And what happened was that in 2016, I think, we had to go do some photo shoot for like some, the media, they like to get all excited about this stuff. And I don't really have, yeah, here's the photo. So here's an actual photo shoot of it. And what they did was they made us take the robots out to Darling Harbour in Sydney. And what happened was when we took them out to Darling Harbour, the journalists were like, oh, can you get them to walk around on the cement? And we were like, okay, we're very careful because like worried about them falling over, because cement's just a different surface, right? And what happened was we turned them on and we would let them walk around and they would trip and they would sometimes fall over. And when they fell over, they would die immediately. And we were like, oh God, they've hit their head, blood force trauma, they're dead. But this happens sometimes. If you hit their head too hard, they used to die. But the thing was that we couldn't actually figure out, because one time it fell and we caught it, and we caught it at like 45 degrees, right? Like it like fell and we like caught it like that, and it died anyway. And we were like, but we caught you softly. You should be okay. Why did you die, robot? And what it turned out was, funnily enough, after all these kinds of extensive time periods, working with this code, I mean, this is just a theory we had. I don't think we ever sat down and verified it, though it made a lot of sense at the time, was that we eventually figured out any time the robot looked into the sun, it died. And we were like, why is that? Why is it dying when it looks into the sun? And it turns out it was because, from what someone told me, maybe they got this wrong, so, I'll blame it on them if they're not true, but it kind of like maxed out the array, because you imagine that an image is literally just a 2D array of pixels, and those pixels have values, and the whiter a pixel is in certain instances, the higher the value is. So it was actually just a massive overflow event, right? Like, this from C. It was literally C code that seg faulted because it overflowed because the sun was so bright that it maxed out all the pixels. So it's like, this is the whole thing again about software verification is, you always need to come at it knowing that you haven't found all the bugs, because there's always going to be more, and you just want to write more tests so that your bugs go from probably nothing to really probably nothing to very unlikely to extremely unlikely, and you'll never really be able to get those two hands together. Do we get to keep the robots? No, we don't. Though we did give an old one to Ian Jacobs. He has one somewhere in his office, the dead one. They die pretty easily. Anyway, let's wrap it up there. Yeah, I'm conscious of people's time. So if you're interested in RoboCup, I don't know who to email these days. I haven't had anything to do with this for like 4 years. They have other teams as well. They have like a search and rescue. Oh no, they have like a at-home robot. I don't even know. I could give you some people to email, but they get mad at me. Don't know. I'll ask around. Anyway, we'll try and chat about these things in weeks if we have some extra time. We'll go over if we can, because it's obviously not assessed. This isn't like accessible stuff. It's just to break up the monotony, because I know that 1531 by its design has a lot of theory stuff, and I understand that we all, including me, have terrible attention spans. So, thank you, and I should really put some feedback up. Did I put this in the feedback form? I don't remember. Did I put it in the feedback form? Someone would know because you fill out the feedback more than me. I think I did. Hope I did. Please fill out feedback if you're here, because I always like to know how these ones go as well. Because anything that isn't well received, we just cut. Everyone's saying bye. I hope it's in here. If it's not, I'm sorry, but if you get a chance, it would be great to fill that out. Just so, again, I get some feedback. But thank you, and we'll see you all next week. You'll get a notice on Friday. Good luck with your iteration 1 deadline on Monday. You'll all be great, I'm sure, and I hope you have fun with the leaderboard. Keep fighting it up.